finish up lesson 3 on refraction and lenses by going over the lesson review. And now one thing I forgot to do yesterday is we forgot to add our reading and vocabulary words to our foldable. So pull that out one last time to add to our notes here. The very last flap is lenses, and we're looking at convex and concave lenses here. So what I did was I took our sketch on page 116 and I added the two pictures of a convex and a concave lens. We want to add in the fact that the greater the curve of the lens, then the more that it bends the light. Here's the definition of lens. It's a transparent object with at least one curved side that causes light to change direction. Here we have a picture of a convex lens. See, it's thicker in the middle. Okay, around the middle it's thick, whereas a concave, it is thick at the edges. So it's real thick at the edges. So we have the light coming in from the side here, and we can see that once it hits the lens, it's going to converge and come to a point. Converge means to come together. And the distance here from the middle of the lens to that point at which it converges is called the focal length. So that's F. We learned that from our virtual lab. And then over here on the concave lens, we have light coming in, and as it hits the lens, it's going to diverge or spread out. Now, if you were to follow those straight lines of light, they would come to a point before it hits the lens, these imaginary lines right here, and the distance between that and the center of the lens is also the focal length or F. Okay? So we're going to use this to look now at our chart here. So we've got, the first one we're going to talk about is the concave. So let's look at it. Concave. All right, is this going to curve inward or curve outward? Does this lens curve inward or curve outward? Go ahead and write that down. Now, does the direction of the refracted light, does it converge and come together, or does it diverge and spread out? What do you think? Write it down. And then for your model, heck, just copy this same picture. That's great. It's a great picture. It's on page 116. You can look at page 116 for that picture, same picture that I drew right here. All right, the next one we're going to do is convex lens here. And what is the direction of the curvature? Does it curve inward or outward as you go from the edges to the center? Next, does it converge the light or does it diverge the light? And finally, our awesome model, which you can just copy this picture. That's great. And label it. All right, the next question is our three-dimensional thinking question. Now this refers back to page 117, which I did not go over, but you can go ahead and read it. It's the life science connection about your eyeball. There's an extra credit assignment about lenses. It's extra credit for nearsightedness and farsightedness. In the lab, the virtual lab, at the end of the virtual lab, there's an extra credit to research some nearsightedness and farsightedness, which gives you a little bit of information here. So, hey, you might as well throw that into your virtual lab and get some extra credit. So which part of the eye, and I've labeled them for you. This is the cornea, this is the iris, the lens, and the retina. Which part of the eye can change its structure or change its shape to form a focused image? So what's part of your eye is going to help focus an image? If you're not sure, you can always look back on page 117. Next, which of the following arguments identifies the best explanation about how a concave lens can be used to start a fire? Which one of these basically is correct? Okay, remember concave lens is this one right here. So look at this picture. Concave lens. Let's see which one of these is true. A concave lens will focus the sun's light into a point that will cause a piece of paper to catch on fire. Can this kind of lens focus to a point? Focus light coming in? B, because the sun's light comes in from all directions, a concave lens will straighten the light out onto a piece of paper. Does light come in from all directions? Does light come in from all directions? C, because a concave lens diverges the light, the sun's light will not focus on paper and there will be no fire. No fire will occur. Does this diverge light? Not allowing you to have make fire? And finally, D, a concave lens will focus the sun's light before the light can reach the paper though, and no fire will occur. So once again, does this type of lens focus the light, but before it reaches the paper? Choose your best answer. Let's turn our page to our real world connection. All right, this is looking at what types of lenses would you recommend if you were an optometrist or an eye doctor. So suppose you see that the light is converged before it reaches the back of the eye. Okay, so what kind of lens would you need? And you can draw a picture as well to help explain your thoughts. And when you draw your picture, you can draw it like this eye right here. Okay, so it's not reaching the part that allows you to see. It has to reach the back of your eye. So somehow this is converging before it's reaching the back of the eye. So what kind of lens would help somebody see if the light is converging before it reaches the back of the eye? So you would need what kind of a lens? It's going to be either convex or concave. And what would that do to the light to help it reach the back of the eye? Finally, number 5, suppose the light never converged at the back of the eye. Okay, so it's coming in, but it's not being focused on the back of the eye there. Never coming together to focus, and so therefore the eye cannot focus. Never converging. What kind of lens would this person's glasses need to be like? Okay, you would need this kind of a lens, concave or convex. And how would that help the light converge on the back of the eye? So which kind of lens helps to make light converge and focus in? Which kind of lens? Convex or concave? Okay, and then go ahead and explain with either a picture or words. Now, as we finish up lesson 3, you want to go back to your science probe, way back on page 105. Let me see if I can go back all the way to how we see a flower and see if you still agree with your same statement and why or why not. Okay, so remember that was looking through a lens. So this is a camera lens. You're going to go through these to see if there's still the one. Do you still agree with the one that you chose? You can change your answer, cross it off if you want to change your answer, and then cross off what you thought or add below now your new thinking, okay? Because now we are revisiting our responses, okay? And of course, we did this yesterday where we went back to our CER and trying to explain a phenomenon on page 109. And I do want you to make sure that you are explaining why you think that in 3 to 5 sentences. So once again, that is right here on page 109, where we revisit our claim about why the polar bear's body looks different in the water. And going back to our picture here, why does the polar bear's body look different in the water than out of the water? Okay, and now you're able to explain that now that you know about different mediums and lenses that can focus. Don't forget to go to the Learn Smart as well as the getting prepared for your lesson check later on, and please study for that. Please use your foldable for your notes, for your lesson check, so you can do your best job. Thanks, guys.